Hello. There we go. That is gonna kind of suck. I think that. Give me a second now. Let me just test this. There. That's normally the microphone. It is not working. I don't know. I guess it is working pretty well. That will work. That will work. Check, check. One, two. That's fine enough. All right. Hmm. Also, look at something here. Did not want- So, mm, give me- All right. All right. So, so- okay. All right. So we ended off, we were looking at some relations that were graphs. Yeah, so I think what I want to do is I want to give you guys a couple graphs that are combinations of kind of some of the elements that you saw in those three, and then I'll have you work through them. Like that. Just wanted to combine a couple elements installed on last three. Like on last three problems that we did on Tuesday. So we'll start with just answer sort of the main three questions: domain, range, and then whether it's a function. Yeah, of course, my usual stuff. So there's that. So I'm just, if you can, I don't know if that's fine. So. So I mean, that's the thing I don't want you to. What is it? Oh, the inner. Right. This is still there. Okay. Let's see that. I'm very grateful. All right, that's kind of what I need to know. So how many of you guys felt like you kind of understood the last thing we did Thursday, but you couldn't put it together for this? And that's fine. Like if that's where you guys are, that's actually what I need to know. Um, so I think then part of it is we might actually come back to negative to two later. We'll see, but let's at least do one. Um, so domain. So just like we were doing at the end on Tuesday, when you have a solid line, curved line, whatever, I can't write all the numbers out. So instead of writing all the numbers out, I do an interval. So does that click? Do you guys remember that? So domain is my x values. So I need my interval has to be everything from something on the left to something on the right. So how far left was this graph go? So -2 is the y value, but you have the right one. So we are looking at kind of this point, this open circle. So remember, what does the open circle mean? Yeah, you're not reaching the value. So it's a point, but we just never reach it. It's like walking, it's like getting closer and closer to a wall, but never actually hitting it. So what is the x value for this point here that we never reach? -3. Yeah. That's a -3. So on the left, my graph, the x values get closer and closer to -3. They just never reach it. So my domain is gonna start from -3, but I'm never gonna reach it. So do I put a square bracket or a parenthesis?
Right.
Parenthesis. Now, on the right, what happens with the x values? Say, yeah, so they keep getting positive, they keep going positive and they just never end. So remember, that's what the arrow is here. You keep going, it's never end. So that's gonna be infinity. Okay, so this is the answer, but I know, like I said, like I was kind of walking around looking at everybody's paper and like you guys, I know you guys understood this on Tuesday because you guys were actually pretty quick about putting those pieces together, but then trying to do it with this little combination. So, okay, so the question I'm trying to get to is, let's do a little like self-analysis. So why do you think you couldn't come up with this, even though you came up with it on Tuesday? Uh, Say it again.
I had like a little brain part, but then I got it, like I got it.
Okay, so brain fart is completely legitimate. Um, what else? What about the rest?
right now I only got convinced. So part of this is I'm gonna ask you guys questions so I can figure out how, like, what's going on with your thinking. But I'm doing that as a, what do you call it, as a sly way of, you should always be prepared. If you don't understand something, it's not just, why don't I understand it, but why wasn't I thinking that? You gotta analyze your own thinking. So for the rest of y'all, why do you think it was kind of hard to come up with this? If you don't know, that's fine, but I'm gonna keep being annoying and ask that question as we go through the class. Because that's actually one of the things that really helps improve learning. You should always be analyzing your intent. You should always be analyzing, why didn't I make that connection? Not just why didn't it make, why doesn't the content make sense, but why didn't I think of it? All right, so that is our domain. Range is my y values. So what? Now I'm thinking y-axis, I'm thinking up and down, so how far down does the graph go? -2. That's gonna be, and we never, because of the open circle, we never reached that point. Right, let me get somebody else to answer, not because you've done anything wrong, but as a teacher, if I only have one person answering, that most likely means 50% of the class doesn't understand anything, and then I'm a pretty horrible teacher. So I'm gonna be annoying the whole class. I'm gonna get different people to answer, because I need to know where 80% of y'all are, not just a couple people. This goes down to -2. What does it go up to? Somebody else tell me, what does it go up to? Yeah. All right, is this a function? Yes, and why? Yes, yeah, they all have different x values, so no repeated x values. Yes, no repeated x values. All right, so if it is a function, like we were talking about last time, we give it a name. So what do y'all want to name this function? Give me a letter, doesn't matter. G. Sure, let's go G. So this is G. So something we didn't get to last time is that once we name a function, we can ask questions about the function using that name. So what I mean by that is we can do something like the following. We can say, I'm gonna write this, G parentheses 1. This parentheses does not mean multiplication. So I think one of the weird things, so this is a very old notation in mathematics. It was introduced by Isaac Newton a long time ago. And because Isaac Newton really did a lot for mathematics, I think in some sense they keep this notation around to kind of honor him. So I want to talk about how you read this, how to work with it. But the first thing is, unfortunately, it does not mean multiplication, even though it looks like that. So the way you read this, you say G of 1. The idea here is 1 is your x value. So they're going to give you the x value. By giving you the x value, there's a question that automatically comes with it. The question is, what is the y value? So they give you the x value, you give them the 1, return the 1. So we got to go to, in this case, our function is a graph. We got to go to our graph and figure out, first of all, where on the function is the x value 1, and then what's the y value that goes with that. So what do you else? So the question is G of 1. So when x is 1, what is the y value? Yes, 0. Sorry. You had it right. I thought I heard C. Let me check on this camera. By the way, give me a second. Let me check on this camera to make sure it's where it needs to be. And still. No, give me a second, y'all.
All right.
Let me mark another point here. One of these. Uh, so I'll just kind of mark that point to show that it's on that line. So another question they'll ask, or another way, so on this one, I gave you the X, you give me the Y. Anything we do in mathematics, we can reverse the process. So I could do the reverse. I could give you the Y and you tell me yes. The way they're gonna write that then is they're gonna say G of X equals -1. They're giving me the Y value. And then they're gonna ask you what the X value is. So again, I kind of conveniently highlighted it just so it's wrong, but when the Y is -1, what is my X? -1. It's- Getting it visually from the graph. So if they give you this G of X equals -1. So again, whatever's in parentheses is your X value, whatever's outside is your Y. So first of all, you gotta read this and know that they're giving you Y. It's outside. And so then you go to your graph, you go to your function, and you find where on that line the Y value is -1, and it's here. So you see that visually just on the graph itself.
Yeah.
Oh, well, no, I put this number here based off of what was on the graph. Yeah, so they're gonna give you some function as a graph, they're gonna use those. Yeah,
G1.
so here is what, it's not that it crossed through, it's just I could have done G of 3 but it wasn't exactly that, so I should use 3.
I'm using points that conveniently are.
And it's easy.
So the G of 1 tells you what.
So the G of 1 tells you X value is 1, it's asking me what the Y value is.
G of X. The X value.
It's telling you Y value, asking what the X is. And that is, you do have to memorize it's a sentence written in very small notation. That I can't kind of, that's kind of how a lot of mathematics works, is we take sentences and we turn it into Python statements, so that we don't have to write one. But it's also.
Yes, that's. Whatever, it's solid.
So if I give you the X, you're giving the Y. It's every functions, relations are about X's in it. So the number about, the last step is about functions, ordered pairs are about Y value. So from now on, you're never gonna see X, Y. You're always. So if I give you 1, then I automatically 1. So you just.
Simply like question.
Yeah.
They do give us like what is the G one?
Yeah, what is the G of X? Yeah,
What is
what is G of X? G of X equals 0. So it is, I am simulating the question, but it's also how you see the question. So this is a very common way to answer that question. So I didn't just make it up out of my head. I didn't make up a new thing. This is in every textbook, math book, this is how they'll ask the question. Yeah. But it's a question. They give you, whatever they're giving you, you're just giving. In this case, I didn't want to go down that equation, so we'll get to the problem where we have an equation, but since my function is a graph, the only way we can get that is to look. It just happened on this graph that where the x is one, the y is. And what other questions? Yeah, let's gonna come back to this last, and it's just a lot of it. Let's do. Rotate this back. One more. What? So everything we've done so far, straight line, didn't actually matter that it's straight. So the main range, we're still gonna look at it. So we've got this curve here. Looking at this domain, left and right, how far left, how far right does this graph? Yeah, all rooms. So on this side, my x values are gonna keep expanding left, very slowly, but they're gonna keep expanding left. And on this side, for all the points that I hit, my x values are gonna keep going right. So this is every. And so we talked last time, we had an example like that last time, so we could say all real numbers as an interval, how would you write this? And yes, so infinity both ways, right? So positive infinity, negative. Negative infinity, positive. All right, we gotta do number two. We're gonna come back to number two, yeah. But we probably won't do this. Actually. What about my range? So it seems like it should be the same, surprisingly it isn't, so more ease.
Bracket.
Yeah. So range is about my y values, how far down, how far up. So this one, when you're going down, it does actually end. So part of the reason I do this problem is to caution you guys, double arrows doesn't mean infinity, infinity. So it's exactly like he was saying, when you scan down, the lowest it goes, so it bottoms out here. And the lowest value is -1, so that's -1. And that's a piece of ink. That's a point, so we reach that value, so -1 with the brackets. But then when I'm going up, how far does it go up? In 50, it keeps going. And also again, notice it goes up on both sides, doesn't matter which side. So that would be the range there.
Those are why values like with the negative right side of the parentheses. That's like kind of order pair next first why.
Gotcha.
It's range, it's just both of those on the
Yes,
side.
both overwise.
But it matters which one you put first.
So good question. It doesn't matter. So mathematically, you could write it this way, you could reverse it, write it infinity, comma -1, as long as you flip the parentheses in the bracket. So mathematically, it doesn't matter. Your homework though, because it's written by a textbook, they want to see it from least to greatest. They want to see it in this. Because one of the little places in the course where the order will matter, not because mathematically it actually matters at all, but because you're entering homework into a textbook.
So that's the correct.
Or, but that's the thing that I want to distinguish, is mathematically it doesn't matter. So you have to be able to hold that in your head. For mathematics, it doesn't matter. But we live in a world where we don't deal with pure, we deal with text. So for your homework, answer this. For me, I'll take either. So like on a test, I would take this, I would take this. It doesn't matter which way you write it. That's. Is it a function? Still a function. I mean, these are pretty steep, but they're not perfect. But we still don't have any points on top. So this is still a function. What do you want to do? Function. Setting. Call this F. Once we name it, we can ask a question about it. Whatever we should. So I think what I want to do then is, let's do these questions in two at a time, but anyway, so we'll do, I want you to figure out f of 0 and f of 2 on this. Since we just had a really good discussion about what that, when they're giving you x and when they're giving you y. So I'm giving you x values.
If it says
Mhm.
any letter a number, that means that's one it's number.
That's the number for the instance, yeah. So really good, I want to kind of repeat what she was asking there, what she said. So yeah, like I said, unfortunately, so anytime you see this written format, letter, parenthesis, number, that number is an extra. It's not asking you to multiply, it's actually an extra. And you read it as obviously,
But I think basically why.
yes, but the whole thing is that it's asking you to, you're giving it one. And again, this is why I think they should get rid of this notation because it's confusing with the way we use parentheses now. It's like, this is, in some sense, this is like honoring your grandfather. They keep using it because the guy who invented this notation essentially invented But anyways, okay, so see if you guys can figure out f of 0 and f of 2. Let's take a couple minutes on that. Right, what do y'all think for? That's gonna be 3 because here's my point with the x value is 0, the y value is 3. Good. What about f of 2?
The negative.
It's negative 3. So here on my curve, here is where the x value is -2, y value is negative. And then when they write it this way, there's doing the same thing but in reverse. So the y value, now they want it. So I'm gonna write this f of x equals 0. Really quick, one thing is you're not gonna keep using 0 like this all the time. I don't want you guys to get stuck on the points that are on the x and y axis, but just these scratches work just that way. So f of x equals 0, I want you to tell me what x is. And take just a minute more and kind of look at that and what that also means.
They're only.
There's two answers in this case. Remember that in real mathematics, there's often more than one answer. These all people from. That's interesting. What do you guys think? So looking at both these points have a y value of 0, so you're gonna do both. So it's 1, 3. Good question. Yeah, so then it's what do we kind of put around? So we're gonna put the parentheses when it's an ordered pair, so an x and a y, or when it's an interval. Are we saying everything from 1 to 3? Yeah, just so. So we're just trying to say those specific ones. So actually, the way you write this is either just like this, or you can put the set brackets around it, the square brackets, but you actually don't use the brackets. Because it's not an order pair, it's not binary. Really good question. I honestly prefer just leave them with set brackets. 'Cause we're also really not talking about set here, we're just saying these are my solutions. See where we are on time.
With the domain for the,
Yeah.
you always have like the negative infinity versus that one versus opposite.
That's also versatile. So any of these are versatile. Good question. It really is just, it's just sort of a tragedy that's, you know, like dealing with textbooks, so just dealing with human, right? So there's perfect way to write it, doesn't matter, but then you have to filter it through humans. So. Not that humans are horrible, but it's just sort of the way we seem to work. That's there. Okay, well, I think. I think we'll just go back in time.
Where's my little?
So let's try to tear this apart. By the way, this is what they call a piecewise defined function. So basically, the key word there is pieces. So we can have functions like we've seen, something like 3, 1, several, all the ones we looked at on, all the ones that were functions on Tuesday, where it's literally just one line object, something like that. Or we can have functions where they literally have more than, you know, that's completely possible. In fact, this comes up a ton in calculus. So I want you to notice on this graph, I've very specifically placed the dots to line up with this whole graph. So we have an open circle and a dot that are the same place in terms of their x value. So you can almost imagine this like, are you guys familiar with the game Mousetrap by any chance? Yes. No, okay. So for those who are familiar with Mousetrap, think about this like Mousetrap. But for those who aren't, so imagine this is like a set of tracks. So you're rolling a marble along this track. So the idea here is I start here and I roll the marble along here. Once I get to this hole, it's kind of like literally like you go down a hole and you come out right here. But because I come out in terms of my x values at the same place, it's almost like nothing ever happened, right? So I'm rolling along this track, I go into this little tunnel and I come out right here and I still just keep rolling there. So even though these are two separate pieces, you want to still think of this as one full roll, roll of the marble all the way across. So with that in mind, we want to think about the domain. So how far left and how far right does my graph look?
And
Yeah, so -4 is the farthest on the left. Right, yeah. So, and here's the thing is, so without this, you'd be exactly right. So, no, but let's talk about method stuff, because I thought about doing one after, like splitting this up into two problems. So without this, this definitely ends at 2 and it never gets there. But with this, that marble just keeps rolling. Okay, so it does actually hit 2 because it hits 2 here. So. So infinity. So this is actually -2 or -4. So step up 2. This is actually -4. And we reach that, and then we keep on rolling out to infinity. You don't mention the 2, and it's only because this dot is lined up right. Yeah, that is correct, just the parentheses. Well. Yes, yeah, so it is, yeah, you prove it, but hold on, what I'm saying is. So right, what you're thinking, would be -4, 2, yes. And then essentially what you're saying, what you're saying to do that.
Right.
Yes, and this basically fills in that hole, but
Oh,
so for sets, instead of all of the two.
what if, what if that line was actually not straight? Awesome.
So like if it's up here,
Like if that, like that, the dot going to the right, like the.
Yeah.
Horizontal line, what if that was on X?
oh, like if it was moved.
What is it?
Yes, then you're right.
There's still being.
There's still be. Yeah, so for sets, anytime you're combining two sets like that, what we can do is combine is what's called that's. That's still. You know. But yeah, you don't have to put the 2 because basically the 2, this 2 fits into the whole issue.
So like that's how the
But so let's. So if it is on the 3. So let me move it for a second. But let's say it is on 3. Then what I see here is I actually have, again, it's one full function, but I have a gap. So my marble is gonna get here and disappear. And come out here, but from 2 to 3. It was out of existence. So the way we would write that is we'd write -4. Then we would write 2, parentheses, it never reaches the 2. And then you use this union symbol. Because, so basically, the union symbol, when we have intervals or sets, it's our way of stating sets together, so you can't use a comma between them, you have to use this. And then what you would write is you basically would write the tracks. So then that would be 3, 2, 10.
But you like the
It fills the gap. Yeah. Yeah.
but we haven't gotten.
I don't think they do it in this book on this homework. So in other books, some books do it in this section for this homework, some books don't. It depends on the book and how rigorous they want us to. So, yeah. So, yeah, this is correct. It's that. So we'll do a similar thing with the links. We did once. But let's talk about the range. The range, how far down and how far up this graph goes. So the lowest it gets is -1, and it doesn't just hit there once, it hits there in a lot of places, but it still doesn't go below. So we hit negative, this is. What about how high? Yes, up to 2. And that's really, I mean, so again, in this case, this open circle really doesn't matter at all, because it's in the middle of all this flat maps. With that, whatever that hole is, it's covered by. There's no infinity. There's no infinities on this one, because when you're thinking up and down, it doesn't keep going up, or it doesn't keep on, yeah. Or no, well, yeah, just for feedback.
But if that bottom line wasn't there and just this open circle.
So let's look at that. So that is the spread. Things bottom line wasn't. Then the lowest it gets is still -1. So this is where I'm saying, remember you asked that question at the beginning, and I was saying you don't want to make too many rules out of this. This is why you don't want to make rules. Because if I change the diagram, like how it looks, then one of your rules is going to not work. So you don't always have parentheses in that. You don't always have an infinity in that area. So like a. You really have to just look at the whole picture. You know, like.
It's hard to like. Don't.
But that's what I'm trying to get you to do, those not remember. So that's, I'm literally saying, as a math teacher, as somebody who has a PhD and has published 5 papers, you try to memorize this, you're gonna get spot answers. Because it's not memorizable. You
Use that to read.
you have to read the graph at Fox. That is. All right, and then. Well, good. Any other questions on that though, before we go to the function part? So let's talk about, is it a function? Yeah, it's still a function. Don't have 2 points above each other, so it's still a function, yes. No repeated x values, blah, blah, blah. Let's call it h. Let's answer some questions about h. I can actually do some stuff that doesn't involve zero.
Okay, X doesn't repeat itself, and there's closed dot and open dot.
Good. It doesn't, because the open dot
Or
means
never.
it never reaches, yes. But really good question, yeah, so that would be the one hitch there. Honestly, this whole open dot and closed dot being right above each other, below each other, whatever. I think of it like if you're hitching a trailer to a truck, you know, it's like you're literally putting. I don't know the words for it, but you're literally putting the circle. So there's still only one X factor. There's still only one.
Oh,
Yeah, if it was closed, then this wouldn't be a function. So let's do h -3. Let's do. No, let's do. What would be these two? That how many flat on the other question on the. So things that are gonna work those two questions. Right, and then we'll get to the other.
And I also have to remember to send this one. Current news. And while you guys are able to send. Lord. I think we're thinking. Well, it's not just that it's close, it's the variance. So it never actually reach that estimate. Which means like, it's like there, that's. All right, let's see what y'all get. So h of -3, what did y'all get there? Yeah, that's gonna be 2. And h of 2, that's gonna be negative. Remember, the open circle means it doesn't really exist, we never get, so you can't say 2, 1, but we do have 2 negative, so it's a hard job. Any questions there? All right, then let's look at the last little bits. Um, so we've had relations given to you, there's just a bunch of ordered pairs, table, arrow diagram, graph. The last way that you'll see a relation, really usually a function given to you is something like this. So I might write f of x equals, let's do plus. And that's squared plus 5, something. So they might give you a relation as an equation. And they can do this because like we just saw, when I put an x, when I put an x value in here, I can do the calculation, it gives me the y value. So this equation basically defines the relationship, shows you y gives y value. But let me get your first thought. What's maybe the disadvantage of an equation versus all the other ways that we've seen for having a relation? You don't see it. There's no list of x and y values. You can't see it on a graph, see it in a table. So that's the major problem with this, is I can't physically see the actual y values. But as long as I plug in an x value, work the calculation through, I get a y value, and I've got it. So you want to think of an equation is more like a recipe for creating pairs rather than just seeing. So because of that, so I will say we'll get to domain and range on something like this. All the domain and range we've been doing is visual, and one of the key things with domain and range is you really need a picture. There is a way to do this algebraically. Domain is not too hard, but range sucks. So we generally don't teach that in these classes because you need to know a lot more algebra just to go back and figure out the ranges. And that just doesn't make sense. That doesn't make any sense. It doesn't make a good teaching. So we will get to domain and range of these as we go. So we're going to spend the next 3 weeks basically graphing, start to graph, maybe not stuff like this, but stuff similar.
So domain range, you need to grab. But we can figure out the order pairs here, so I could ask you maybe f of -2. So I'm giving you the x value. You can't see the y value, but you can go and calculate. So again, I'm telling you x is -2. So then to calculate it, what would you have to do on the right side? Plug it in. So everywhere I see an x, I replace it with negative. And then I go do my calculation. What I wanna do is I wanna give you guys a second to do this calculation because I wanna see, so if you get it wrong, that's fine, I wanna see where you are, whether you can use order of operations. All this stuff correctly. So take a minute to work out that.
Yeah, but yeah, that's the, you got it. Well, little can fall. Nah, it's on. That's what we need. Honestly, it's 5 minutes to figure out why I'm so then. So I'll bring you guys to calculators to do this and that and then. Did you see? What? You, this. Which, I don't get. Just send a text, on the volunteers. Yeah, yeah.
Did you just pick a random number 92, or you're saying that's what the answer was to the first?
Yeah, I am picking, and now I am just picking a random number. Yeah. And it's only because we have a graph, so we don't have something where something works or it's not. Great. There's a couple of words, yeah, is. One. Third. It's like living, but it was fun. It was, yeah, there's somebody like the. All right, let's see what element. So I don't want the answer yet. I want you to kind of take me through the steps here. So what do we do first? Yes, so we'll do x one. So what was -2 cubes? -8. What about -2 squared? 4, 7 times 4 plus 5. Good. And what do we do? Yeah, so multiply next. What's -7 times 4? -28. Good.
Okay.
We can do the -20 plus 5.
Yeah, this is actually.
So -8 minus -23 minus 23.
Minus.
Oh, but I know, the same thing.
One, eight, three, shoot.
So you should have got -31 minutes. Okay, so that's good. That means you guys have no problem with the order of operations or kind of doing these calculations. So then let's look at it. Yeah, it should.
Or just.
I mean, technically this is actually why. It would be why.
Why?
I mean, honestly, like, so for me, you don't need to, because I understand in the context of the problem what it is. And then on the homework, I think that sometimes they have the whiteboard there and sometimes they're not even consistent, so. Give us this function. We'll do g of n minus 3. And now I'm not saying x is a number, I'm not plugging in a number, I'm saying it's n minus 3. But even if you feel like you don't know exactly what to do, that based on what we've seen so far. So over here, x was -2, so I replaced x with -2. What would you, how would you start this?
X is out.
Not the cube, but exactly, setting it.
Putting the X out.
Yeah. So it ends up that the way you start this is exactly the same. That doesn't change, like the fact that you have a variable there doesn't change anything. You're still just, we call this substitution, but you're still just plugging. So everywhere you see an x, instead of an x, you're writing n minus 3. I've got n minus 3 squared. Plus 4 times n minus 3 minus 2. The difference here is obviously once you plug that in, like, in calculate. But what they're testing here is, do you kind of remember what to do with something like n minus 3 squared or 4 times n minus 3? So they're testing some of the skills we're assuming. So if you don't, that's also figured out. Let's start with the 4 times the n minus 3. So do you guys remember, what do I do with something like that? You distribute. So I'm gonna do 4 times n and 4 times -3. And again, they're just looking for, you'll see that actually all throughout this class. So anytime you see sort of this setup, like you just one thing times another, as long as it involves variables, then instead of actually doing calculation, you're always doing distribution. Multiplication is always distribution. So even this n minus 3 squared, so when you square something, what is that? So surprisingly not, you have actually the right name, I just like that word. So like for instance, when we did, yes, multiply by itself. So like when we did -2 squared, we did -2 times negative. So you can think about it like you literally take a picture of the thing, there's 2 of them next to each other, multiplication. So the same thing here, n minus 3 squared is not n squared and 3 squared, it's, you take a picture of that and you place it next to itself. And you do multiplication. That's really what I mean by n minus 3 squared. And then pick back to previous class, how do you do this? It's still distribution. So again, the running joke for multiplication in algebra is no matter what you're, where you see it, you're always doing distribution. So we're gonna do n times n times negative. N multiplied through. And then we're gonna take the -3 and multiply through again. Yeah, so let's kind of start working on what's n times n? N squared. What is n times -3? Minus 3n. And then we'll go to the -3. What's -3 times n? -3 times -3. Positive 9. Now let's go to the second distribution. We gotta do what's 4 times n? It's 4n. 4 minus 12. Then we still just have this lonely -2 on the. And then we add, so multiplication is always distribution. When you're adding and subtracting with variables, it's always combining. So actually, I can run a joke, no matter where we see it in this class, if you're adding and subtracting variables. So what do you see there? Where are my like terms? Good. So not just the 4n's. Yeah, so we have -3n, -3n plus 4n. So does everybody see? So. Yes, so -2. And then we have 9 minus 12 minus 2. -5. And that's our base. So on 4, I plugged in a number, I got it. On 5, I plug in variables, I get variables. So that's what you should always expect, it's input. So that's mechanics, but any questions there? If not, that's good, because that means you guys have good things. So honestly, like stuff like this, like if you got it, you're like, okay, well, why is it a big deal? It's a big deal because almost every problem in this course is gonna involve skills. And so that's really why they made a big deal out of the previous class, is because you get clear on this stuff about it. Public service announcements, because the food stuff, so if you guys have never been, Angels Next to Haven, which is just up a couple blocks. It's freaking good, and if you get just water, you can actually with tip get a meal there for like $10. So it's really good. The service is cheap. I always go there. It's fun. So,
What you recommend? So you get.
Chilaquiles. The chilaquiles, the amigos is still on chilaquiles. So,
I know it's on their sandwiches.
yeah.
Yeah.
There, and otherwise. What do you call it? That'll get you through the homework, work, honestly, like, here's one. So. Well, so you'll see the homework outcomes. Yeah, I mean, it's the same homework that we started on Tuesday. If you finish that, you're good. Didn't finish the homework, that's finishing. It's important right now. Questions for? Oh, that is, you need 2 books. Yay, 2, fine. That's a good solution. You know, it's gonna come out. Being good fun. That is literally, yeah, I mean, This, I mean, not that like that is not at all your fault, it's just gotta be create something like, yeah, definitely never give your numbers in those situations. Yeah, 30 minutes, honestly, like, you know, make sure it's making. What is 10% of the these kids? Just, so now you're trading, like, I need money on the big picture.
Yeah, should be, why not?
It's.
And the,
Yeah.
like that.
It's not, I mean, so I'm doing this the first couple weeks, I basically gotta have a record of the first couple weeks, so that if somebody doesn't show up, I can justify them. But beyond that, we're all, so if you don't come to class, then like, just get in, find somebody who has the notes, and just go online.
I like that you always like post what's been on the class, that way,
Yeah.
I get an idea of what it is.
Yeah,
And then like turning in the homework, like that's gonna, and doing this, like all of that work counts more than it.
yeah, and that is kind of my point, is like, it should,
I
it should,
like Fredericksburg, Texas, that's like an hour, I make an hour to get
you
here.
say it where?
Fredericksburg, Texas.
Oh, yeah, okay, yeah,
So sometimes like,
that's, yeah,
if
no,
there's something,
I understand, yeah, that is far away.
it's, okay, so, thank you.
Okay, sure.
Have a good one.
Hmm.